Today we're going to learn how to use an explicit function to find the nth term. Before we do that, let's take a quick review of our vocab. An arithmetic sequence means constant addition. A geometric sequence means constant multiplication. And when you're writing these in the explicit formula, it's composed of two things: an initial value and a pattern. Here we can see the initial value and the pattern. When it's arithmetic, the pattern is called the common difference. D for difference. In a geometric, you will see once again the initial value and the pattern. In a geometric, the pattern is called the common ratio. R for ratio. Now let's try finding the nth term. Nth term simply means any term. So if we look at problem 1, we're being asked to find the fifth term of the sequence. That's simple enough. I'm already given the first, second, and third term, so it shouldn't be too hard to find the fifth term. I just need to find the pattern. It looks like this pattern is I am adding by 2. So let me continue that pattern until I find the fifth term. Great, it looks like our fifth term, or a sub 5, is 4. That was pretty easy. The next one's a little more challenging. Find the seventh term of the sequence. Well, it gave me the first, second, and third term, so I just need to continue the pattern a couple more times to find the fourth term, fifth term, sixth term, and then over here the seventh term. So let me identify the pattern. It looks like I'm multiplying by -4. So if that pattern continues, we should be able to find our seventh number. If we multiply 32 by -4, we get -128. Multiply by 4 again, we get 512. By -4 again, we get -2048. Multiply by -4 one last time to see that our seventh number is 8,192. So our seventh number, a sub n, equals 8,192. Finding the nth or any term is pretty easy when we're finding terms that are relatively early on in the list, like the fifth or the seventh. But it gets more challenging when we're finding terms way later on in the list, like the 60th term. When you're being asked to find those, you're going to want to write the equation and then use the equation. So let's do that. First, I see my initial value is -29. And now I see that my pattern is subtract 20. This is going to be an arithmetic sequence because I'm constantly adding a negative number. So let's write our equation. My initial value was -29. My common difference was -20. Now I need to know when n is 60, when I'm standing at the 60th place in this list, what number is there? So let's figure it out. A sub 60 equals -29 minus 20 times 60 minus 1. We simplify. And I see that my 60th number is negative 1,209. So A sub 60, my 60th number, is negative 1,209. Let's try another example. We need to find the 14th term. So n equals 14. We're going to need to write our equation and then use our equation. Our initial value is 6, and our pattern is to multiply by negative 3. Since I'm multiplying, that's going to be a geometric equation. Let's go ahead and write it. My initial value of 6 times my common ratio of negative 3 to the n minus 1 power. And we're looking for the 14th term. So A sub 14 equals 6 times negative 3 raised to the 14 minus 1 power. We start to simplify, and we see that our 14th term is negative 9,565,938. So A sub 14 is that number. To summarize, make sure you write your equation and then use your equation.